Okay, today we're going to finish up 7.3. Yesterday we talked about the different theorems to prove parallelograms, right? Today we're going to talk about identifying a parallelogram inside of a coordinate plane. So first, it gives you the coordinates of a quadrilateral and asks us to prove that it is a parallelogram. So we're going to talk about 3 different ways that you can do that, and then you'll have time to practice that. Okay, so first thing I want you to do, graph the 4 coordinates on the coordinate plane. Bless you. All right. Everybody get those drawn in. So, method 1 says to show that opposite sides are parallel. How could I show that opposite sides are parallel? Slope, right? So, we want to find the slope of opposite sides. So, we're going to do AB. What is opposite of AB? DC. And then BC. And opposite of BC is AD. Okay, so we're going to find the slope of each of those. Remember, variable for slope is m. That's why I'm writing that in here. Okay. Now, we're going to use just rise over run. So if I want to go from point A to point B, how could I get there? Up 2 over 5. Okay, so my slope there, 2/5. Same thing from D to C, up 2 over 5. So those two match up. Right? So we know these two are parallel because their slopes are exactly the same. Okay? Then we're going to do B to C, down 1, 2, 3, over 1, 2, 3. So what would negative 3 over 3 give you? Negative 1. Okay? Same thing from A to D, 1, 2, 3 down, 3 over, also negative 1. Okay? So, did we just prove that this is a parallelogram? Yes, because we know opposite sides are parallel because they have the same slopes. So, method 1, to me, this is the easiest way. Okay? Because it's pretty easy for us to just count rise over run. Yes? Mm-hmm. Method 2 is going to be the longest one. So, like, most of you, when you get to choose, are going to choose method 1. Or method 3 is not, method 3 doesn't take long either, but most of us will choose 1. But we have to know method 2 because it does ask you to practice some of those today as well. Method 2 says to show opposite sides are congruent. How would I be able to show that opposite sides are congruent? What would I have to know? Not a trick question. The length. Yeah. How can I find the length? What are you going to have to use? Distance formula. Okay. So, same ones. We have AB, DC, BC, and AD. Now, it might be helpful, right? Like when I do AB, I'm using these 2 ordered pairs, okay? So I'm just going to subtract the values and square them, right? So what am I subtracting here? Truthfully, you guys, it doesn't matter which one you put first. As long as you remember to subtract them and square them, you're going to get it correct.
X minus X.
Okay, so negative 3 minus 2 squared plus 3 minus 5 squared. Bless you. Okay, now just because I don't have a ton of room to work all this out, we're going to just use our brains a little bit. What's negative 3 minus 2?
Negative 5.
And then negative 5 squared would give you 25, okay? What's 3 minus 5? 2 squared,
4.
okay? 25 plus 4 would give you
29.
square root of 29. You don't even have to take the square root, you guys. You can just leave it as square root of 29, right? Because if I get the same thing on the second one, won't I know square root of 29 is the same as square root of 29?
Yeah.
Yes, okay? And don't you already know that's what you're going to get on this one for your answer? Because we already proved it was a parallelogram, okay? All right, so now we're going to move on and we're going to do DC. So same idea, we're just using different ordered pairs, okay? What am I subtracting for DC? 5 minus 0 squared plus what? 2 minus 0. So essentially, we just have 5 squared. What is 5 squared? 25, like we just had, plus 4, right? So same length on opposite sides here. Now we just need to go and check DC and AD. Okay, somebody else tell me, what am I subtracting for BC?
5 minus 2.
Okay, and what else?
7 squared plus 5 minus 2. Or 2 minus
2 minus 5, yeah. Which I guess you're squaring, so we'll get the same answer. But always, whatever you start with, use that same one. Okay? All right, what's 5 minus 2?
3.
And 3 squared?
9.
9. What's 2 minus 5?
Negative 3.
And then negative 3 squared is also 9. Okay? So we get square root of 18. Is everybody okay with how the pace we're moving through this at? Just making sure I'm not losing anybody here. All right, last one. A and D. So negative 3 minus 0 plus 3 minus 0. So same idea, negative 3 squared is going to give us positive 9. 3 squared is going to give you also positive 9. Okay. Not too bad, right? I know this one takes a little more time, but I think most of us are used to using distance formula. Okay? Questions on either of those? All right, last one says, show the diagonals bisect each other. So if I can prove that those two things bisect each other, or, not or, but meaning they have the same midpoint. So if each of those diagonals has the same midpoint, then we know they bisect each other because they're crossing at the same place, okay? How do we find midpoint? What is that?
Isn't that like the x2 minus x, or is it plus?
Plus.
Then divided by 2.
Yep. Add our x's, take half. Add our y's, take half. Okay, so here's what you have to think about on this. My first diagonal is what line segment? AC. Okay, now again, I'm going back up here because it's easier. They're already written up here, so I'm going to go back up and underline A and C. Okay, so what x values am I adding together for AC?
5 and -3.
So -3 plus 5, and then I'm going to take half. What about for y?
3 minus 2.
3 plus 2,
Oh, yeah.
take half. Okay, so what's -3 plus 5?
2.
And then 2 divided by 2.
1.
What's 3 plus 2?
5.
Half of 5,
2.5.
2.5. Okay, then we're just going to do the same thing. We're going to check this time BD. So for BD, we're using 2, 5, and 0, 0. Okay, so for my x's, I'm adding 2 plus 0, taking half, and then I'm adding 5 plus 0, taking half of those. Everyone knows where you got those numbers, yes?
Yeah.
Okay, what's 2 plus 0? Half of 2.
1,
5 plus 0. Half of 5. 2.5. Okay? So, here's your 3 different ways to solve. Again, slope's the easiest. Diagonals are probably going to be second easiest. Distance formula is going to take the longest, but still, I kind of showed you guys, you don't have to give me every single step when you do distance formula, okay? Plug it in, go from there, okay? Fair enough? All right.